Hi and Assalamualaikum everyone. So today we are from Group 4 from Class A4 AS120218. We would like to present our MAT183 video presentation, which is applied of maximum and minimum problems. These are the group members who are involved in this video presentation. First, NURATIRA SYAHIRAH. Second, Razia binti Rahim. And last, UMMI KHAIRIYAH binti TAUFIK. The objective of this topic is first to be able to solve the problems that related to maximum and minimum problem. Second, to apply the first derivative and second derivative formula in the maximum and minimum problems.
In differentiation, the maximum point and the minimum point of a function are known as the largest and the smallest value each function can occupy at a point. Many application problems in calculus involve a set of functions that need us to determine the maximum or minimum values. If the function of f(x) is continuous, then for every continuous function on a closed interval has a maximum value and a minimum value. The function together with its domain will suggest which technique is appropriate to use in determining a maximum or minimum value, also known as the extreme value theorem, first derivative test, or the second derivative test. For the extreme value theorem, we use this method in finding the possible maximum and minimum values of a function on certain intervals. If the function of f(x) is a continuous function on a closed interval ab, then it has a maximum and minimum value on ab. The extreme value theorem can be determined if the function is continuous on the closed interval. Next, we need to determine all the critical points of the function in the given interval and evaluate the function at these critical points and at the endpoints of the interval. The highest function value from the previous step will be the maximum value, while the lowest function value is the minimum value of the function on a given interval. For the first derivative test, if f'(x) changes its sign from positive to negative, then the point C at which it happens is called local maxima, whereas for if f'(x) changes its sign from negative to positive, then the point C at which it happens is called local minima. And lastly, if f'(x) does not change its sign as x increases through C, then the point C is the point of inflection. For the second derivative test, if the question needs us to find the values of x for which f'(x) is equal to 0, these points are called critical points. If the f'(x) is more than 0, then the point is the minimum point, whereas if the f'(x) is less than 0, then the point is the maximum value, and if the f'(x) is equal to 0, then we need to use the first derivative again to check if the point is the point of inflection, the local maximum, or the local minimum.
Example: Brahman bought 10 flowers and vase together to give it to his mother for Mother's Day. While trying to put together the bouquet, he accidentally knocked the vase off the table and broke it to pieces. Help Brahman figure out the right measurement to buy another vase that he can use to replace the one he broke before his mom came back from work. The flowers have a maximum height of 25 centimeters square. First question. If the surface area for 10 flowers is 25 pi cm square, write H in the terms of R. So because in the question we are using cylinder-shaped vase, so we must know the formula for surface area for cylinder, which is 2 pi RH plus 2 pi R square. And then we substitute the value given for the surface area, which is 25 pi. Rearrange all the formulas, and then lastly we get H equals to 25 over 2R minus R. Show that the volume of the vase needed is 25 over 2 pi R minus pi R cubed. So first we must know the formula of volume for cylinder, which is pi R square H, and then from the value of H at the question earlier is 25 over 2r minus r. So we substitute the value, we arrange all the equation, and then we got the answer that we wanted, which is 25 over 2 pi r minus pi r cube. Find the maximum value of H that Rahman needs to find so that he can use it with the flowers. So we all know in a maximum and a minimum type of question, we must differentiate twice to know that the value we have is a maximum or a minimum value. So we first differentiate the value of volume that we got on second question, which is 25 over 2 pi r minus pi r cube. Differentiate that and we have 35 over 2 pi minus 3 pi r squared. So we use the power rule to get this value. So we all know in a maximum and a minimum, the dv over dr must be equal to 0. Substitute this value to the equation. Then we got r equal to 2.041 cm. So in the second derivative, we differentiate again the value of volume on the first derivative, which is 25 over 2 pi minus 3 pi r squared. Differentiate that again. Then we got negative 6 pi r. So we substitute the value of r and the first derivative into the second derivative. Then we got negative 38.48. So we all know this value is less than 0. So the value that we have earlier is a maximum value. So because we want to know the maximum value of H, so you must substitute this value of R into the equation that we have on the first question. So we substitute that, we arrange that, and we got H equal to 23.47 cm. So because the maximum value of flowers that we have is 25 cm square, so technically the vase must be a little bit shorter than the flowers to make it make sense. So because the value we have is less than 25, so this value is acceptable.
For the conclusion, there are various applications where involving maximum and minimum values when a certain quantity is needed to be solved. This application may be found in the world of economics and also industries such as businesses and engineering. Many of these can be solved using the differential calculus method. Thus, everything that we can see in this world may be based on the concept of maximum and minimum that provide a solution to the related problems, as we always compute the maximum and minimum values of some data set.